Hello, so for the DYN5 Ethernet IP demo, our hardware setup is the productivity PLC P1000 going through a switch right here, going to the drive, and then with our computer all connected from the switch. So the first thing to do is to check the PC's IP address, so IPv4 properties, and the IP address of whatever you set to should have the subnet mask set to 255.255 and 00. So this is the setting for my PC because the servo drive uses the last two bytes of the IP address as significant to identify itself. So you have to set to 255.255.00 on the PC side. Do OK. Close out of that. So our drive is already connected to the computer, but let me just double check the IP address. Or actually, sorry, the COM port for the drive. COM port for the drive is 4. That's fine. So for the servo drive, make sure that it is set to Ethernet mode, and also the IP address is set to a usable value. From right now, it's set to 192.168.50 and 18. 192.168 to match each device in the network, and then the 50 and 18 to identify the servo drive itself. So it says Modbus TCP here, but it's the same for Ethernet IP. So that's fine for the servo drive. So close out of that. And if we open up the productivity PLC program here, let me create a new project actually. Let's save this project. No. Okay, so if you create a new project, I know my CPU is P1540. Continue. Use PC project. So the first thing I want to do is check the CPU. So here's my CPU. I want to do the change CPU / IP address name. So the CPU should be set to 192.168 whatever, and then the subnet should also be set to 255.255 and 00. So my PLC is set to 192.168.48 and 13. Yeah, so that's fine. Okay, I think we're already connected, so it's fine. So close out of that. So the first thing I want to do is read from the diagnostic counter, which if we see in our specification here, the diagnostic counter is parameter instance 255, and this just increments the data in this register by 1 area after each read. So that's good for using it to diagnose or test the communication. Usually start with a counting contact here, a 2-second contact bit that rises every 2 seconds. So start with that, and we go with hardware configuration to set up the servo drive, Ethernet IP, generic client. We'll call that DYN5 1. CPU, that's fine. IP address of the drive is 192.168.50.18. Use structure for the status, so DYN5 underscore EIP status 1 is okay, and it'll ask me to create all the tags. That's fine. Default is fine. So that's created, and let's do an Ethernet IP message, explicit message, which is over here, and drag that into our count 2-second rising bit. So DYN5.1, that's fine. Device. You have to select the service. Let's do generic. We have to do generic service ID. We want to read. So the read service is, or the get is service 14. So we should do service 14. Class is the parameter class, which is 16, or actually it is, sorry, parameter class is 15. Read from parameter class 15, attribute is always 1, and then the instance for the diagnostic counter, as we see here, is 255. So 255 instance, and the structure for this read status, we just do, let's call it status 1. And then let's read into a data tag called data1. Data1, all of the data from the to and from the drive is 32-bit long, so 32 bits is okay, and it's okay, and it's asking us to create a tag for this, all these data for this tag, the status tag. It's default is fine. And that should be it for all that. Compile and then transfer to CPU. So after a second, after it finishes transfer, if we open up the monitor, it should be reading. So every time this increments by 1, it should be reading from the diagnostic counter, which is just incrementing by 1 each time, as you can see here. That's stored in data 1. This drive has been powered on for quite a while, so it's just not starting from 0, but it'll start from 0 and go up to, it'll keep counting, just to make sure that it's in communication. So so that's the explicit read. Let's set up the implicit connection before we do an implicit write. So the implicit connection, we are going to hardware configuration, double click on our drive, set up an IO message here. Delivery option for the input, which is from the drive to the PLC, everything has to be unicast. RPI time is leave it default. So for the assembly instance, for the input, which is this part right here, has to be 100. So 100, and the input is actually 16 bytes, because we have the input from the drive to the controller is position, speed, torque, and status, and each of these is 32 bits. So 4 times 4 bytes is 16 bytes long. So we have to do total of 16 bytes of input. So we can just create input. Just create a data block called input 1, and 32 bits. That's correct, because each data is 32 bits, and then we create 4 columns for 4 data, and then we use all 4 columns of that data, of that block. So for the output, include a status header. The output instance is 101, 101, and then output 1 as the data array. Output 1 is data array, and it is the output from the PLC to the drive is only one data block, so it is just one 32-bit data, 4-byte data. So just this one output, one column of 32-bit data is correct, and we're using 1. And also for the configuration data, we don't need to enable the configuration data. So that's done. So that's saved. I'll compile this project, and then let's write it again into the PLC. So we have to write into a PLC. We just open up our data view to check, and then we have to turn on that implicit message, by the way. So we have to go, what was our DYN5 drive? DYN5 drive 1 is our device name. So our device 5.1, DYN5. DYN5 status, what's called DYN5. ST1, and our message, our IO message was message 1, so we have to do message 1 enable. Actually, before that, let's just put in our data here first. So our input was called input 1, and our output was called output 1. So these two are all set up, data displayed right here. And as soon as we enable this message 1, and we write to the PLC, message 1, send this edit. So it's enabled, message 1 is enabled, and we can see the IO data coming in from the drive. So this one, input 1, so this was the position, speed, torque, and the drive status, and this output to the drive right here is the drive enable disable. So as I rotate, try to move the motor shaft with my hand, you can see the position of the motor changing, and also the speed and the torque the drive is applying to the motor to try to keep it in position. So That's the I/O. So what I'm doing right now is just trying to manipulate the motor position with my hand, but it's locking it. So you can see the position is changing on screen here. Let's do